Good morning and welcome to the first of our panel discussions today, inspection techniques in a miniaturized world. Inspection technologies have evolved in recent years beyond visual inspection techniques to include metrology and sophisticated data-driven process and line control systems. This panel is going to discuss some of the recent developments and challenges presented by miniaturization. I'm joined on the end by Brian D'Amico from Murtec.
Pleasure to see you, Trev. Thank you for having me.
Thank you. Next to him is Joel Scotchfield from Co-Young.
Good morning. And again, yes, thank you for the opportunity.
Thank
you.
you.
Good to be here.
And our resident expert, Mr. Keith Bryant from Keith Bryant Consultancy.
Good morning, Trevor.
Okay, so thank you for joining me, gentlemen. Let me get straight in. First question. How important is metrology and digitization in modern inspection systems?
Metrology is very important. What we're looking at here is, with the advent of 3D, we're inspecting everything on the board, but we're actually getting the data back from those inspections. We're looking at length, width, height measurement, coplanarity for everything. So it's really important to know exactly what's happening on a PCB. By taking the difference between like 2D and 3D, by taking all of this information, we can then refine the process and make the machines do exactly what they should do, and that's making the line work and manufacture as best as possible. So maximizing your efficiency and getting rid of errors very quickly and easily. You know, 2D, you're not really looking at this information, looking at a 2D image. You don't know the true length, width, or height measurement of a device.
Right.
So it's very important, especially as devices get much smaller, then it becomes extremely important because visually or with a 2D system, you're simply not going to be able to see very small devices beyond 01005s, which is what we're kind of talking about here with miniaturization, right?
Right. Okay.
And I'll add to that if I could. Brian's absolutely right. But there's another piece to this as well, right? And we're all involved in that, and that's the use of
AI.
Machine learning, AI, the big data sets to optimize optics, and I think that's really what's going to take us next level, right? Or next level down.
Right.
in no pun intended, miniaturization, right? So it's a combination, again, of everything that Brian described, and now using that data, using that big data to apply to machine learning and proprietary artificial intelligence engines that use that proprietary centric data to optimize and again, provide capabilities for next level inspection.
Right. Yeah. I mean, I think the AI is coming in already in some of the learning programs. You know, it's much faster now to program these systems. You know, and AI is playing quite a role in that. Do you have a view on it?
Yeah, definitely. I mean, the other thing that it's helping with is speed.
Yeah.
Because when you get miniaturization, not always do the boards get smaller. You just have more and more components with more and more density and harder to see things on the same board. So you need the speed and also the accuracy to be able to do a decent inspection job without slowing down the production line if you're looking at either AOI, SPI, or X-ray as an inline product. You know, it's got to be able to keep up with the line, and everybody wants faster line speeds, and they're just making real challenges because they're sticking more stuff on the board that's harder to look at.
Right. But I mean, here's the thing. I mean, you're generating all this additional data, which you've got to crunch and be able to turn that into useful data and actionable information. So that you've got to have that on the other end as well. So the computing power and the ability to interpret that data is equally important.
Yeah, and I think it all ties together, Trevor. I mean, what you're getting into now is grabber speeds, transmission speeds, processing speeds, as you've referred to. You know, we have to utilize the technology to push the limits of all of those to be able to do what we want to do. That you know, camera technology is not maxed out, but to take it next level, we have to utilize all these tools and maybe even proprietary optics, proprietary cameras, et cetera, et cetera. So yeah, there's certainly room to move, but we have to use that data basically, and again, maximize that with all of the technology that we have available through artificial intelligence.
Right. Well, camera technology was actually my next question. I mean, and I'll put it to you first, Brian. I mean, has camera technology reached its limits, and or can we expect more enhancements?
Absolutely not. So we at Mertec, we manufacture our own cameras through our division called ISVI.
Right.
So in manufacturing those cameras, we're pretty much in tune with camera technology. The thing about the cameras are they do have to be specifically developed for the inspection process.
If you haven't already done so, please stop in the
I
show
can't compete.
office by 3 p.m. today to select your lottery number for next year's event. The show office is located in the lobby of Hall D, next to registration.
The beauties of live broadcasting at a trade show.
I can't compete with her.
Yeah, no, you can't. No, you can't compete with that. Sorry to interrupt you. So
no, that's fine.
want
So
to
the bottom line is we manufacture our own cameras, so we kind of know about the technology there, right? The different sensors that are available, and it is not maxed out by no means. We're currently working on our next generation of cameras as well. Miniaturization is driving that effort to design new camera technology.
Right.
You know, building in the proper signal-to-noise ratios that are required for measuring small devices repeatedly every single time.
Yeah.
That's something you just can't buy from an off-the-shelf camera. So we are very much in tune with that. And no, it's not maxed out at all. It's continuing, and technology is continuing as always to go by that entire mantra of smaller, cheaper, faster. That drives manufacturers. And if manufacturers of inspection equipment don't really adhere to that mantra, they're going to fall by the wayside. So it's very important to stay in tune with the latest technology.
latest technology. Keith, I'm going to put an X-ray question to you because you're the X-ray expert on here. And where are we in terms of tube technology for X-ray inspection?
Tube technology for the size of the components, we're pretty able to see anything that you want fairly easily. Even the mid-range systems, if you've got an angled view so you can look at joints, they'll show you what you need, but they take some time. But the problem is when the balls get smaller and the joints get smaller, any cracks or voids or whatever that you see inside those get smaller as well.
Right.
And that's pushing not only the tube technology, but the detector technology. But the other thing that comes in on the back of this, of course, is you want speed. So you need an X-ray source with high flux so that you can get the image very quickly off the flat panel and do all the work that you need to with it, and then move on to the next thing that you need to look at.
Right.
So yeah, X-ray is probably more challenged by the faults of miniaturization than the AOI guys are at the moment.
Right, right. What sort of resolutions do you get down to? I mean, because we're coming in the advanced packaging world. They're going into the sub-5 micron space. It's
yeah. I mean, X-ray machines and tubes at the high end are getting well below that. 5 micron resolution is I would describe as your normal basic for anything that you need to do. Obviously, with inline systems, it's different because you need to look at a larger field of view because you want to work faster.
Yeah.
So that's not so much of a resolution issue. It's more about the quality of the detector and the flux that comes out of the tube to make the image.
Right.
But, there are tubes out there now that are half a micron, and there's one out there now which is being developed, which is goes down to 150 nanometers as a real resolution guide scene. So, that doesn't get you into the five nanos that the TSMC and guys are making the chips, but it gets you down to see really small features within the components themselves.
Right.
And that's going to be over the next couple of years. That's probably going to be a game changer because it's also a system with quite high flux, so it works quite quickly.
Right.
So that's going to be
interesting.
an interesting thing for our futures.
Absolutely.
Trevor, if I can, I just want to add to something that Brian said and something that you said as well. So kind of a hybrid on both. Getting back to the camera technology, we also have our proprietary camera technology, and it's the advanced packaging initiative that I think is driving all of us to continue to improve and to be able to address the needs of that particular sector.
Right.
As I think we're all in that world to some degree, but with things going on right now with the CHIPS Act and everything else that's involved with that, there's certainly incentive to take that to the next level, right? So you see a lot of that being driven, camera technology in particular, the ability to inspect the needs of that particular sector by that initiative.
Right.
So, yeah, we're ready or not, here it comes.
Yeah.
Oh,
So,
yeah. If you look at the Custer Consulting numbers that I check out on a regular basis, you know, high-end semiconductor equipment spend is compound annual growth of something like 20% forecast for the next 5 or 6 years.
Yeah.
So yeah, you know, that's the space to be in.
That's the space to be in, yeah.
And the fact that everything's moving around at the moment, also, you know, you're not going to try and move a fab line that's set up. You know, you're going to mothball it, sell it off to somebody else, and you're going to set the new one up in a new place with brand new equipment. So yeah, it's definitely an exciting time.
and that's what we're hearing from the. Oh, I'm sorry, from the.
Okay, so I mean, you're absolutely right, gentlemen. But one of you're all excited, so I get that. But no, it's not just the advanced packaging side that's presenting challenges, miniaturization challenges. We've got these micro LEDs coming in now and mini LEDs. What specific issues does that present in terms of inspection? I mean, what are you looking for in these things?
Well, first and foremost, the reflectivity challenges, right? So anything with a shiny surface, glass, shiny surface, dye, etc., is going to present an issue to, you know, standard moire, if you will. So now we look at a little different approach where we're basically fusing moire and coaxial lighting, and I know Mirtec has some technology as well. And there's some other things going on with that put us in a position to overcome that, right? Because it's like I said, it's not only mini micro LED, but it's also shiny dye and all of those other challenges that come along with the advanced packaging applications. So yes, there's definitely a twist, and of course in our world, that's where we move to the Meister series to address those issues. So.
But Brian, I mean, do you need to also check that these things are straight? You know, I mean,
absolutely.
when you're working with these really small mini LEDs and things like that, you have to make sure they're straight, because otherwise it's going to affect the luminance, the color, etc. in these messaging systems.
Yeah, that's extremely important. So Mirtec, we just actually were getting ready to release some information about it. Our Genesis LED system, which is designed for micro mini LEDs, very small LEDs. But we've been selling systems for doing LED inspection for years, like Samsung, LG, all of the backplanes. When it comes to LEDs, the most important part, like you said, you got to make sure that they're all facing the right way, and the illumination is correct. Otherwise, you got to throw the board away or rework the board, and that's not it. So when you're dealing with like a backplane that has what's called BLU, backlight units to them, you have to make sure those LEDs are rotated properly. They're not, you know, splayed in any way. And of course, when it comes down to inspecting like the lens on these things, you're talking about things like confocal measurement, things where you can measure like the height of water with this kind of thing, right? It's not like, and that's where moire does fall down. When you're looking at like these lenses that are see-through, transparent, there's no way to inspect that with moire. There's no way to inspect that with a laser.
Right.
But confocal measurement is really the way to do that. Like I said, you can inspect the height of water.
Yeah.
So it does impact the design of the system, because there's inherent weaknesses to all of the technologies that exist currently for inspecting boards. And as things get smaller and smaller, those LEDs get smaller and smaller, then we have to not only deal with those different ways of trying to at least see the data, right? At least see what's there, but also we have to deal with a higher resolution. It's very important, right? Because
they're using them in car headlights and things like that now, and
cool.
these things are fairly critical. You know, you can't have them deviating the beam from there.
Yeah, and it's not only XY; it's a relative position from one to the other, or a centroid somewhere that says every one of those is in the exact right centroid position to illuminate properly, as you said, Trevor. So yeah, there's challenges, but again, there's technology to address it.
we can do it.
We can do that.
All right, my next question. Let's see. Is it important to keep inspection systems separate from production machines? Not sure what I mean by that, but I mean, is it?
You mean rather than building AOI into a pick and place?
Yes.
Yeah.
Yes.
Yeah.
Yes, that's what I mean.
Yeah, we don't advocate that. Or I should say we advocate keeping them separate as opposed to trying to, adapt our technology, let's say our source, our sensor into, a system being manufactured by an integrator or something
Right.
of that sort. That's more for the camera guys, right? That just the 2D guys, if you will.
Well, I mean, you are getting some people. Some manufacturers of pick and place machines are putting obviously AOI and rudimentary AOI into their systems. Some of them are also putting in other types of inspection for counterfeit and things like that. There are systems there. Is that an area that you guys would get involved in at some point?
No, and I do want to address a little bit more about having inspection built into a system like, say, a screen printer. You have inspection built into that. So our machines, we develop and manufacture Cartesian robot systems, right?
Mm-hmm.
So we're talking about moving over to where the region of interest is, being able to use a light ring that's specially designed to illuminate that FOV as best as possible, multiple different LED lights to have different colors that get as much information as possible, having 3D sensors on there as well. Mm-hmm. There's a lot of stuff built into the head of the robot.
Right.
And in a Cartesian system, that gets moved from frame to frame to frame. Now, there are other like higher speed type applications that may be built in, whether it be like a laser scanning technology or perhaps downward cameras that are used to strobe and capture images. But there are inherent weaknesses with those types of inspection principles. And that's where you're not going to get the same as if you had a standalone system that was specifically designed to do SPI inspection, AOI inspection, and inspect the board really, really well. Side angle cameras, in order to put that into say a system like a screen printer or a pick and place machine, you would require the same size head that we currently have, which is a pretty big head.
Right.
And there's no way in heck that you could possibly do that. Mm-hmm. So I do recommend if somebody doesn't have any inspection capability, it's okay. But if you're really looking to maximize the inspection capability of your line, it's just not going to get you there.
Not going to get you
That's the way it is.
I agree with everything Brian said. There's just too many moving parts. There's too many factors, and we all have our secret sauce. And trying to just adapt that as a one-off, take this from here, put it here, and expect the exact same results, where you can't control all those external elements, external lighting, et cetera. The other thing is cycle time, right? So, parallel processing is much more desirable to constant beat rates on the line. And if you start to incorporate too many additional processes into one system, you've basically slowed down your line potentially, right? So
it's like having a 3-in-1 printer, kind of, But
I have one of those.
You have one of those, yeah, and they work. But I get it. I mean, it does. You're right. It would slow down cycle time, and it's probably better to have it as a separate function, but communicating with that printer or pick and place machine.
Yeah, I think if you want to put something into a printer, then a jet dispenser for solder paste that will fill in the gaps that the SPI finds, you've got something. I mean, that's a really useful tool. Brings a lot of benefits. Doesn't take a lot of time. But to try and put two machines into one box, which effectively is what you've got to try and do, it's a non-starter, I think.
Yeah. Okay. All right. I'll take that. Okay. So my next question. Let's see. Should inspection companies offer central libraries where EMS companies involved in non-sensitive manufacturing can benefit? Now, this is an interesting one because we're in an age now where we're getting some of these big software guys are pulling off data from lines from tier 1 customers around the world, and that tier 1 customer is getting the benefit of all these machines from around the world and been able to map trends, optimize their systems, which is giving them a real differentiator between the smaller guys in the field, the tier 3s and the tier 4s, who've only got one line or a couple of lines, and they're not getting the benefit of that. So the question is basically, should there be a central library where they can, we can share the data? What do you think?
I agree with it. I think it's a great concept. Bottom line is, if you could take it requires a lot more cooperation. If you're talking about being able to take data from different manufacturers and take it and pull it, and then because you're basically giving their competition a bit of an edge at times when you think of it that way. But I do kind of agree. We've had more cooperation in this industry than I've ever seen before. And if that's something that, and there are, in many ways, we of course provide our libraries to our customers, and they're very extensive. But there's always the opportunity to make that more extensive. And I think that being able to capitalize on all the knowledge that's out there would be the right thing to do.
Yeah.
A little intricate, but I think it'd be the right thing to do. So I agree with that concept.
Yeah.
Yeah, and especially from a programming perspective too, right? We get that question a lot, and again, that's a push, right? We want to use the same parts library that we're using here in the U.S., in China, in Europe, and have everything built to the exact same standard, no deviations, so we can move product without having to reprogramming, retune, et cetera, et cetera. Easier said than done.
Yeah.
But we're certainly working in that direction, right? We'll start with a plant, then start with multiple plants, and then grow from there. But it's certainly something we get asked about, especially by the big multinationals, and maybe not even asked about, maybe told that, okay, we're gonna do this at some point. So, what do we have to do to make that happen?
Right.
You're not talking about just in intercompany. You're talking about other companies as well having access to this information.
Yeah,
correct?
I mean, other companies
That's
that
the
are able
difference.
to
Of
share
course-
that are allowed to share their data, because obviously this wouldn't apply to companies that are ITAR registered
Right.
or doing anything like that. But companies that are doing industrial automation and stuff like that and wanting to optimize their process.
Yeah, I mean, I think you guys are almost a long way there, because you've got pretty good parts libraries already. And when you've got a component, you know how many legs it's got, you know how many, you know where the legs are, you know how big the legs are. And that component is the same all over the world. But when you start looking at joints, and then you have people who are making bare circuit boards from different places, they're using different surface finishes, they're using different design rules to make the pads, so the joint shapes all look different. I think if you go beyond components, which is a standard thing, and that in itself is a great help. But if you start saying, a joint on this SOIC should look like this, it's dependent on too many other things. And if you're a multinational company, you've got one set of design rules, you buy your boards from probably just one or two companies, you can make even that work. But when you start trying to give that information to other people that are getting different boards with different finishes and different pad sizes, then you're not generating anything that's a benefit. You're just making a nightmare for the poor guys.
Well, I don't know.
Yeah.
It's easier said than done. But I mean, there is already, of course, IPC 610A, which gives you all the information on how the shape of what shape your joint should be and your tolerances and that sort of thing.
Yeah,
I
but
agree
it
with
does it
100%
within
though.
limits. Yeah.
Yeah.
Because like you said, the different processes out there, the different solders out there, the different pad structures. Even though we know what a solder joint should look like, and should test
Should
like
look like,
for
yeah.
IPC 610A, there's going to be changes like that.
Yeah,
Now,
absolutely.
what would be really cool is being able to collect that type of information somehow. Being able to collect that type of information, say if you're using this solder and this kind of pad structure, this reduction, home plating on devices, this is what you should be looking at. That would be kind of cool, but that's beyond the components themselves.
Yeah.
That's a really good point, Keith.
Good. Okay, guys. Well, as I say, I think it's going to be an interesting area moving forward. I think we're going to see more of this. But for now, I think we've run out of time on this particular debate. Now, I want to thank you all for coming in and taking part. So, Brian D'Amico from Murtec.
Thank you.
Thank you, Trevor.
Joel Scotchfield from
Did you break
Go
yours?
Young. And, of course, Keith Bryant from Keith Bryant
I guess
Consultancy.
I talked enough.
Yeah, there you go.
Thanks,
So-
Trevor.
Okay, so thank you, gentlemen, and thank you to our audience for watching.
The Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important. Expand your inspection capabilities. Inspect in 5 directions using top and 4-angled cameras simultaneously. Find defects that a single camera can't detect, such as OCR and QFN solder bridge. Best in class performance 18 megapixel sensor.